Alright, in this problem, you have Maurice accelerating upward at 5 meters per second squared. That means he's moving up. If we were to draw a free body diagram for this, we would have the dot here. Going down, we would have the force of gravity, which is also another word for weight. In the opposite direction, we would have his normal force, Fn. In this case, Maurice is accelerating upward, so you would expect this upwards arrow to be bigger. When we draw a free body diagram, one of the reasons we draw it is so that we can find out f of g, and we can find out f of n. And then we can add these two together to get the net force. So, first things I'm going to write are the fact that A is equal to 5 meters per second squared. We also know from Maurice's force of gravity from the previous example that his force of gravity is equal to mass times the acceleration due to gravity, mg. And in the previous example, we calculated it to be 100 times negative 9.81 meters per second squared, which gives us minus 981 newtons. This equals the downwards arrow in the free body diagram. It equals f of g. It is also the same thing as Maurice's weight at rest, or at a constant speed. This is one of the first things we figured out in the previous example. Another thing we can use is the fact that for any net force, it's equal to the mass of the object and the overall acceleration. This is Newton's second law. Maurice's mass in this case is 100 kilograms, and his acceleration from this problem is 5 meters per second squared. If we multiply those two together, we get 100 times 5, which is 500 newtons. This is the net force of this whole free body diagram. These two things might be hard to calculate if you didn't know what you were calculating. That's why one of the first steps that you could start with actually is saying that the net force of this whole problem is equal to the normal force plus the force of gravity. In our previous lessons, we've looked at how to calculate net force. You just have to add the arrows together, and that gives you the sum of everything, which is another word for saying net force. One thing that the question asks is, what is his normal force? Another way to say that is, what does the scale, so scales, bathroom scales, the scales that measure your weight, actually measure normal force? So that's actually what we're going to be looking for in this problem. We've already solved for F net. F net comes from this 500 here. Fg comes from this negative 981 here. And all we have to do is plug everything in. So we get 500 newtons is equal to the normal force minus 981 newtons. In order to solve for Fn, we add 981 newtons to both sides, and we get a normal force, or what the scale measures as 1,481 newtons. If you look at this number is much bigger than the 981 newtons that we have calculated. And this shows that this number means Maurice is accelerating up, and he's getting heavier.